Hi, I'm Freddy Schisler.
And I'm Treyton Cox.
And Dr. Cleveland, this is our Build a Family project.
The two people that we chose to use for this project are Kamala Harris and Donald J. Trump.
For the first trait of complete dominance, we decided to do height. The big T stands for tall and it's dominant, and the little t stands for short and it's recessive. Donald Trump is 6'3", so we put him as tall, and his genotype is big T, little t, and phenotype, yeah, he's tall. Kamala Harris, she is 5'4", so she's short, so we put two little t's for short, and their potential offspring are shown in this Punnett square. The genotypic ratio is 0 homozygous dominant tall, 2 heterozygous dominant heterozygous tall, and 2 homozygous recessive tall, which can be reduced to 0, 1, 1. The probabilities of them being tall is 50%, and of being short is 50%. Yeah. Then this is the photo, so that's them, and these are their offspring. And the son is tall, and the daughter is short.
So for our codominance trait, we chose to do hair color, meaning they will both have, both of them will come together. So we have HBL, which stands for blonde and is the dominant. Then we have HBR, which stands for brown, which is also dominant because it is codominance. So Donald Trump, the father, his genotype is HBL because he is blonde, meaning that is his phenotype. And Kamala Harris, who is the mother, her genotype is HBR because she has brown hair, and that is her phenotype. So if we look at our Punnett square here, our offspring potential, the genotypic ratio will be 0 blonde hair, H blonde hair, and 4 HBR to 0 brown hair, HBR. And the genotypic probabilities is 100%, so they will have a mix of blonde and brown hair. And the phenotypic ratio is 0 blonde, 4 mixed, 0 brown, which can be reduced down to 0, 1, 0. And the phenotypic probability is 100% that they will have mixed colored hair. So this is our pictures here. So the son, his genotype is HBR, probability 100%. So his phenotype is mixed, which is also 100%. And then the daughter is the same thing.
For the next trait, for incomplete dominance, we chose skin color. So the big the W stands for white and it's dominant, and the B stands for brown and is also dominant because in codominance, both traits will be expressed. Donald Trump, the father, his genotype is big W, and his phenotype is white. Kamala Harris, the mother, her genotype is big B, and she has brown skin. Their offspring potential, the genotypic ratio is 0 homozygous dominant white, 4 heterozygous white, and 0 brown, which can be reduced to 0, 1, 0. The genotypic probabilities are 100% that it's going to be heterozygous white. The phenotypic ratio is also 0, 4, 0, and that means that it'll be, which can be reduced to 0, 1, 0, and that means that there's a 100% chance that they will have mixed offspring. So these are the pictures of brown skin, and the son has 100% and his genotype is WB, and the daughter also has 100% and her genotype is WB.
So for a sex-linked trait, we chose to do potential net worth. So XR, or X capital R, stands for high potential net worth, which is dominant, and then X little r stands for low potential net worth, which is recessive. So Donald Trump, the father, because he is worth a lot more than Kamala Harris, his genotype is X capital R Y, and his phenotype is he has a high potential net worth. And then Kamala Harris, since she is not as rich as Donald Trump, her genotype is going to be X little r, and her phenotype is low potential net worth. So for their offsprings, offspring potential, the genotypic ratio is going to be 2X big R, 2X little r to 2X R Y, and the genotypic probabilities is 50% of X big R, X little r, and 50% of 2X little r to Y. And the phenotypic ratio is 2 high potential net worth to 2 low potential net worth, and the phenotypic probability is 50% high potential net worth to 50% low potential net worth. So from these pictures, we can see that the son, since he is going to get the trait from the mom, his probability is going to be 100% of not a high potential for a high net worth. So his phenotype is going to be low potential for net worth, which is 100% probability. And then the daughter, since she gets the dominant allele from Donald Trump, she will have a phenotype of a high potential net worth, and her genotype is going to be X big R to X little r.
For our multifactorial trait, we chose political party affiliation. So R stands for Republican and it is dominant, and little r stands for Democrat and it's recessive. Donald Trump, the father, is a big Republican, so his genotype is big R, and his phenotype is Republican. Kamala Harris, the mother, her genotype is little r, and her phenotype is Democrat. The potential offspring, the ratio, genotypic ratio, is 0 homozygous dominant big R to 4 heterozygous big R to 0 homozygous recessive little r. The genotypic probabilities, it's 100% big R heterozygous big R little r. The phenotypic ratio is 4 Republican to 0 Democrat, and the phenotypic probability is 100% Republican. However, it is important to note that for multifactorial traits, it also takes into account the environment which the offspring and individuals live in. So we've chosen that the son and daughter will probably be living with Donald Trump, and because of that, when they see his Republican views, that will also help the expression of the Republican. So the son will have a genotype of big R little r and probability of 100% Republican, and the daughter will have big R little r probability of 100% Republican. Sorry, Dr. Cleveland, we had technical difficulties, but this is our last slide.
So the total probabilities of the genotypes and phenotypes. So for the son, his genotype is going to be heterozygous, big T, little t, HBL, HBR, WB, X, little r, Y, and then big R, little r. And his phenotype is going to be tall. He's going to have hair with brown and blonde streaks. He's going to be mixed light brown skin. He's going to have a low potential net worth, and he's going to be a Republican. So the total probability of this happening is half times 1 times 1 times half times 1 equals 1/4 or 25%. And for the daughter, her genotype is going to be little t, HBL, HBR, WB, X big R, X little r, and RR. Her phenotype is going to be short, hair with brown and blonde streaks, mixed light brown skin, high potential net worth. She's also going to be Republican. And the total probability is going to be half times 1 times 1 times half times 1, which is going to be equal to 1/4 or 25%.
A picture is worth 1,000 words. Thanks for watching our presentation.